Imagine yourself embarking on an exhilarating hike up a towering mountain. As you ascend, you feel a noticeable change in the air. It becomes crisper, cleaner, and decidedly colder. This phenomenon, my friends, is no mere sensation. It's the tangible effect of lapse rate. In the simplest terms, lapse rate refers to the rate at which the atmosphere's temperature decreases with an increase in altitude. It's a fundamental principle of atmospheric science, governing everything from weather patterns to the formation of clouds. Picture the Earth's atmosphere as a giant layer cake, with each layer representing a different altitude. As we climb higher through these atmospheric layers, we're essentially moving away from the Earth's surface, the primary source of heat. The ground, warmed by the sun's radiant energy, heats the air closest to it. As we venture farther from this heat source, the air temperature naturally decreases. Understanding this concept is key to grasping the dynamics of our atmosphere. Now let's delve a little deeper into the scientific underpinnings of this atmospheric cooling. The decrease in temperature with altitude is primarily due to a decrease in atmospheric pressure. Air pressure is simply the weight of the atmosphere above a given point. As we ascend, there's less air above us, resulting in lower atmospheric pressure. Lower pressure, in turn, allows air parcels to expand. And here's the crux of the matter: as air expands, it cools. Think of it like this. Imagine a bicycle pump. When you compress the air inside, increasing pressure, the pump feels warmer. Conversely, when you release the air, decreasing pressure, it cools down. The same principle applies to rising air parcels in the atmosphere. As they encounter lower pressure at higher altitudes, they expand and cool. This cooling effect is what drives the phenomenon of lapse rate. But wait, there's more. It's not as simple as a single uniform rate of cooling throughout the atmosphere. We encounter different lapse rates depending on the atmospheric conditions. Let's break down three key types: environmental lapse rate, dry adiabatic lapse rate, and moist adiabatic lapse rate. The environmental lapse rate, as the name suggests, is the actual rate of temperature change with altitude at a particular time and location. It's what we measure with weather balloons and is influenced by a host of factors, including geographic location, time of day, and weather systems. The dry adiabatic lapse rate, on the other hand, refers to the rate at which a dry parcel of air cools as it rises. Dry air here simply means air that's not saturated with water vapor. The dry adiabatic lapse rate is approximately 5.5 degrees Fahrenheit per 1,000 feet. Finally, we have the moist adiabatic lapse rate, which comes into play when a rising parcel of air is saturated with water vapor. As this moist air rises and cools, the water vapor condenses, releasing heat. This release of heat slows down the cooling process, resulting in a lower lapse rate compared to the dry adiabatic lapse rate. Understanding lapse rate is crucial for a wide range of applications, from predicting weather patterns to managing air quality. In meteorology, lapse rate plays a pivotal role in determining atmospheric stability. A steep lapse rate, meaning rapid cooling with altitude, indicates an unstable atmosphere, conducive to the formation of thunderstorms and severe weather. Conversely, a shallow lapse rate suggests a more stable atmosphere. Lapse rate is also instrumental in understanding pollution dispersion. Pollutants released at ground level can become trapped beneath a layer of warm air, a phenomenon known as a temperature inversion. Temperature inversions, characterized by an increase in temperature with altitude, a negative lapse rate, can exacerbate air pollution by preventing pollutants from dispersing. By grasping the concept of lapse rate in its various forms, we gain a deeper appreciation for the intricacies of our atmosphere. From the refreshing coolness we feel atop a mountain to the formation of towering storm clouds, lapse rate is a fundamental principle shaping the air we breathe and the weather we experience.